one last titration video. So I'm on page 21 in your Unit 9 packet, and I just want to work through a couple of these. Again, just a way to review our two different types of titration problems. Let's start with number 1. So number 1 asks, what mass in grams of scandium hydroxide will be required to react with 25.0 milliliters of 0.2 molar sulfuric acid? All right, so as I read through this question's asking me to find the mass in grams. When I see that in a titration problem, I know that I have to make that substitution on one side of my formula. That on one side of MEV equals MEV, I'm going to plug in moles for molarity times volume. And I just need to figure out which side. So it's asking for grams of our base. So that means on the base side, I will plug in moles instead of molarity and volume. But don't forget, you got to put that equivalency back in there. All right, and then let me go back. It means I should know MEV for my acid. It's 0.2 molar. It's diprotic. And also don't forget, when you do that substitution, what unit do we need for volume? That's right, we need liters. So 0.2 times 2 times 0.025 divided by 3. And I'm going to have 0.00333 moles of my base. And that's my first part. To finish this, I want to know, or I need to know grams. So I know that I have to get rid of moles. And then what do I need to know to go from moles to grams? I'll give you a hint. It involves the periodic table. We need to get our molar mass of scandium hydroxide. Molar mass should be 95.99. So after I multiply through and divide by 1 mole, well, really dividing by 1 does nothing, I get that final answer of 0.320 grams of scandium hydroxide. Now, I will do one more of these sort of problems. But again, the key thing is just remembering when you're dealing with molar mass or mass in grams, you have to first make that substitution in, and then also make sure that your volume is in moles. And let's try another one of those. Let's try number 3. So number 3 asks, or tells us that we have 1.432 grams of an unknown monoprotic acid that we titrate with 50 milliliters of 0.484 molar sodium hydroxide. And we want to know the molar mass of the acid. Oh, it's another molar mass problem. So we should be thinking substitute in moles. And this time it's going to go on the acid side because that's what we're trying to find. So we substitute in moles for molarity and volume, but we still have to put equivalency in there. It's monoprotic, so that's a 1. And then we set that equal to our molarity of our base, 0.484, times its equivalence, it's NaOH, it's 1. And then that volume of 50 milliliters, remember that has to be in liters. So take that 50 and divide it by 1,000. Again, remember to go milliliters to liters, divide by 1,000. So I do my math here, and I figure out that my moles of acid that I had, or that reacted, is 0.0242 moles. Now this question is a little bit different than number 1. It's not asking for grams, it's asking for molar mass. So remember, final step is a little bit different. Remember, to find molar mass, we're going to take the number of grams that should be given to us in the problem, and then we divide that by our number of moles. So 1.432 divided by 0.0242, and we get our molar mass of 59.2 grams per mole. So again, those are the kind of two types of molar mass and mass titration calculations we can make. I do want to do one more on this page with you all, and let's take a look at number 2. So number 2 says if we have 10 milliliters of 0.004 molar KOH, and they neutralize 35 milliliters of our diprotic acid, determine the pH. A little bit different, right? This doesn't ask for grams or molar mass. It asks for pH. So let's think about this. How do we get pH again? Okay, well, we know normally, if we're talking about an acid, because again, that's what we're looking for, pH of the acid, we know to find pH, it's usually the negative log of the concentration of that acid. Well, is there any way for us to get the concentration of the acid? If you answered yes, you're exactly right. Remember the concentration of our acid, that H+, remember that is Ma. That's our molarity of the acid. Let me write that a little bit nicer maybe, so it doesn't look like a Q. There we go. But remember, H+ concentration, that is our molarity of the acid. So that's what we're trying to find. So molarity of the acid is our X. It's diprotic, so EA is 2. And in this case, we can leave volume in milliliters because we're not dealing with mass or grams. And then molarity of the base, 0.0040 molar. KOH is monoprotic, and then the volume of 10.0 milliliters. Okay, now we can do our work. 0.004 times 1 times 10 divided by 2 times 35. And we get our molarity of the acid as being 5.71 times 10 to the negative 4th molar. Now, you might have also gotten this number on your calculator, 0.000571, something like that. Those are the same. Number 1 is just scientific notation, and the other is standard notation. So now that we have the molarity of our acid, now we can go back to our pH formula. So we know our pH is just the negative log of that concentration. And here we might just be content to be done, but here's something I've kind of been trying to warn you all about. We have to remember if we have di or triprotic acids or bases. We may have to make sure we get that concentration and multiply it by that subscript. So we have to make sure, because this is diprotic, before we take the negative log, we have to multiply that concentration times 2. So remember, diprotic tells us it's H2. So after we multiply it by 2, we take that negative log, and then we get that pH of 2.94. Good luck with the rest of the page. Again, remember, you're always welcome to email, leave comments. You have multiple avenues on ways to get some extra help.